So in this video we're going to look at two things, one of which is what's called a greatest common factor. So two things we just want to be aware of with greatest common factor. One is the greatest common factor is the biggest number that can be divided into a group of numbers or a pair of numbers. And then if we're talking about variables, we're basically looking at the number of variables that a group of terms have in common. So when we start talking about examples, and here's one here, we're looking at, for this greatest common factor of 6 and 10, I'm looking for what's the biggest number that both 6 and 10, what's the biggest number that divides into 6 and 10 evenly. So if you take a look at the numbers that can go into 6 and 10, you have 1, you have 2, you have 3, and there's 6, and then there's, for 10, there's 1, there's 2, there's 5, and there's 10. So I'm basically looking for what's the biggest number that they both have in common. So in this case, we would say that it's a 2 that they have in common. So we would say the greatest common factor here is 2. 2 is the biggest number that can go into both 6 and 10. However, there is a way to do this in your calculator. So if you take your calculator and you go to math and go use your right arrow key, go over to number, 9 down here is the greatest common factor, or your calculator, it says GCD, which is greatest common divisor. So if I push 9 and then I put the numbers in, I have to separate them with a comma. So if I do 6, 10, close my parentheses here, it will give me what the greatest common factor is there. So that's another thing that you can do in your calculator to get your answer to something like that. So if we have variables, and what we're looking at with variables is we're looking at what they have in common. So if I take x squared and x to the fourth and I rewrite these without exponents, so remember x squared would be x times x to the fourth would be x times itself 4 times. And what I'm looking for here is what they have in common. So if you notice, they have a set of x's in common, they also have another set of x's in common. So since there are two pairs of x's that they would have in common, we would say the greatest common factor for this would be x squared. So you have something like that for the variables. So if we take a problem where there's two different variables, so once again, this would be x squared y cubed would be x times x, and then we have y times y times y, and then for x cubed y to the fourth, right, we have x times x times x, and then we have y to the fourth, which would be y times itself 4 times. So once again, I'm just looking for what they have in common. So there's a set of x's in common, there's another set of x's in common, then I have a set of y's in common, another set of y's in common, and then another set of y's in common. So what they have in common, how many sets they have in common, is the answer here. So we would say the GCF for this would be, since there's two sets of x's in common, we would say x squared, and since there's 3 sets of y's in common, we would say y cubed. So one of the things I just want to kind of point out to you, a little bit of a shortcut here with the variables, is with GCF, I take you back to this here, the shortcut for this is when you're comparing two variables, the variable with the lower exponent is the GCF. So if you have x squared and x to the fourth, the GCF would be x squared, since that's the lower of the two exponents. And the same thing here with this right here. If we're comparing x squared and y cubed, the GCF would be x squared, because that's the variable with the lower exponent. And then when I have y cubed y to the fourth, since this is the lower exponent, that would be the answer that goes here. So that's the shortcut that saves you from having to do all this, writing it out and circling the pairs and all that kind of stuff. So if you take something like this, just kind of talking shortcuts here, so I'm looking for what's the biggest number that goes into 6 and 11. So the biggest number that goes into 6 and 11 is 1. So if you're not sure what that would be, once again, you can go to your calculator here, and I can do math, right arrow key, and then 9, and I can put in 6, 11, and that will give me what the GCF is for the numbers. And then if you're comparing variables, x to the first, x cubed, so since this is the variable with the smaller exponent, we would say the GCF for that would be x. So the answer for this would just be 1x, or just x by itself. So that's just some different things with GCF. We're also going to look at least common multiple. So least common multiple, when you're trying to find the least common multiple for a pair of numbers, you're looking for what's the least or the smallest number that a pair of numbers can divide into. and the common variables is the one with the least common multiple is the variable with the higher exponent. So when we were talking GCF and exponents, we were talking the GCF was always when you're comparing variables that are the same, it's the variable with the lower power. When we're talking about least common multiple in variables, the least common multiple is the variable with the higher power. So if we're talking about the least common multiple for 6 and 10, what I'm basically looking for here is what's the smallest number that both 6 and 10 go into. So two different things kind of go over here. One is if you can tell what the answer is just from looking at this, then that's obviously great. So I'm looking at 30 would be the least common multiple here because 30 is the lowest number that both 6 and 10 divide into. Now your calculator also does least common multiple, so it's on the same screen as the greatest common factor. So if I go to math and use my right arrow key and go to 8, 8 is least common multiple. So if I put in here the numbers 6 and 10, so I got 6 comma 10, that will also give you what the least common multiple is. So that's another thing that you can do in your calculator there. So if we have x squared and x to the fourth, so when we were talking about greatest common factor, if the variables were the same, we were saying that the greatest common factor was the variable with the smaller exponent. With least common multiple, it's the opposite. It's the variable with the larger exponent. So the least common multiple here would be x to the fourth for something like that. So GCF, smaller exponent, LCM, bigger exponent. So when I go to do this, and I'm just going to do this each part like one at a time, so I got for LCM, I got x squared and x cubed. So this would be x cubed, bigger exponent, and then you have y cubed and y to the fourth, bigger exponent. So you'd have that there. So that's the LCM for those. And then when we kind of take all this and put it together, so now when you have 6 and 11, the biggest or the smallest number that 6 and 11 both go into would be 66. So if you can do that in your head, great. If you can't, then I'm coming back to here again. I got math, right arrow key, and then 8, and I'm just going to put in here 6 comma 11. So when I do that, there's the least common multiple, the lowest number that both 6 and 11 divide into. Now for the variables, I have x and x cubed. So once again, LCM, variable with the higher power, that would be x cubed. So you have that there for the least common multiple. So just a couple things to keep in mind. Greatest common factor, that's the biggest number or the greatest number that can divide into a pair of numbers. And when you're talking about variables, the greatest common factor when comparing two variables, it's the variable with the lower power. And then when you're looking at least common multiple, that's the lowest or the smallest number that a pair of numbers can both divide into. And when you're talking about least common multiple for variables, if you're comparing two variables that are the same, it's always the variable with the highest power.